Okay. Now is it recording?
Yeah.
Perfect. All right. Thank you everyone for joining. I appreciate you all coming in as you are. Please put where you are coming to us from, what you teach if you are a teacher, what you're studying if you're a student. And I know I just said it, but I wasn't recording. I do want to give a shout out to someone who is supporting his wife going into labor right now. And I appreciate you sending a note. So thank you. You will get a recording of this that you can watch while your baby is sleeping, because that will happen in the first day and then never again for like 18 years. Thank you guys for joining. We have with us two phenomenal educators. We have Artist Harold, we have Justine Sheen. They are both coming to us from the Vera Rubin Observatory, and they are going to share some really incredible investigations. If you were here with us last month, you saw some data-driven astronomy that can be brought into the classroom. They are going to share some more really incredible real data from classrooms or from some telescopes that you can bring into your classrooms. Really neat stuff. I saw a little bit of the presentation, would have made my teaching life significantly easier. I'm Christine from the National Astronomy Education Coordinators with IAU's Office of Astronomy Education. Bill Waller is my colleague who is here. We are both coming to you from the East Coast of the United States. So I have, before we get started, I have a question for Artis and for Justine. If there was an animal that really embodied who you are, or like the characteristics of you, in the US we'd say like it's a spirit animal, what would be your animal?
Ooh, okay, I'll go first. Thanks, Christine, for the quick introduction. I'm a little bit biased. So my last name used to be Fox. So that's my maiden name. And I actually think that is also my spirit animal, mainly because I like to think quick on my feet, kind of like how a fox can be quick and sly. I think I have some similar characteristics in there too.
Excellent. Artis.
I don't know that this is who I am, but who I would love to be is an animal, a horse. I think horses are beautiful, they're graceful, they're sensitive. Um, they just, and I used to have horses growing up, so I still have a very special place in my heart for horses.
Excellent. I used to ride horses as well. So if you guys have some questions during the chat, there is a Q&A function. If you could put your questions there, there will be a Q&A session at the end of this webinar. You'll have the opportunity to ask Justine and Artis some questions if they don't answer it during and you can ask participants questions as well in the chat, but we ask that if it is related to what they are talking about, if you could please put that in the Q&A. That's where we'll be looking for questions, but feel free to have some dialogue with each other in the chat as we are going through. And I'm just so thankful to have everyone here and to have Artis and Justine. They work so hard to be able to just bring really incredible opportunities to teachers everywhere, to be able to make this free. And they're both just phenomenal women and phenomenal educators. So thank you guys. I'm going to turn it over to you.
Thanks, Christine. So hello, everyone. I'm Justine Sheen. I am coming in from Tucson, Arizona to join this webinar. I work for NSF Noir Lab as an education specialist, and 25% of my time I get to spend with Rubin Observatory and designing these online interactive investigations. I work a lot with artists as well. So thank you for joining us today. I'm going to turn it over to Artis to just introduce herself one more time.
Hi, everyone. I'm Artist Harold, previously a high school teacher and did some college on the side. I spent all of my teaching years in Michigan, and I've been working with Rubin Observatory now for 8 years as an education specialist.
And so if you all could take some time to introduce yourself in chat, let us know where you're chiming in from tonight. And if you do happen to teach, we're curious, what grade levels do you teach, and what do you teach? So for the webinar tonight, our goal, or depending upon where you're chiming in from, it could be the morning. I heard Christine mention there are a lot of folks from Indonesia. That's awesome. Everyone is welcome here. Our goal today is to learn more about Rubin Observatory's investigations and all the support materials that are available for educators. And then we are also going to explore 3 of our investigations. So there's 7 investigations in total that are ready for you to bring into your classroom today. But we're going to just do a quick preview of 3 of them. So I was able to watch the last webinar that Christine put on with Nick, and I loved it. So I tried to design this webinar to have a similar format as well, just kind of giving you an overview of what we have, and then we can answer your questions at the end of the webinar as well.
I'm going to take a little while to introduce to you Rubin Observatory. If you have not heard of it, Rubin Observatory is part of NSF Noir Lab, part of the U.S. ground-based optical infrared telescope system. We're located in Chile, nearest to the city of La Serena. You can see here on a map approximately the location of our observatory, which is where a number of other observatories are located as well, in the foothills of the Andes Mountains, where the air is high, dry, stable, and just excellent observing conditions for astronomy. Rubin Observatory has been under construction for 10 years. We're incredibly excited to tell you that we are closing out our construction period, and we are in just a few months going to be able to share with you our first light images. If you've not heard of Dr. Rubin, Vera Rubin was an American astronomer who provided the first convincing evidence of dark matter. She was a strong advocate for women in astronomy. She believed that anybody who wanted to do science should be able to do so. And we've adopted that same kind of mantra for our Rubin EPO, our Education and Public Outreach Program, and for our classroom investigations. As you can see here, we are the first major United States observatory named after a woman. Rubin has a unique system of 3 kinds of innovative technology. We have the largest digital camera in the world that provides a very wide field of view, wide images. We have a very speedy and lightweight telescope that will allow us to take many images per night. And we have an incredibly high resolution camera that allows us to not only see faint objects, but objects in great detail. And combining these 3, what we're going to do is a survey of the night sky from our location in Chile. So pretty much like the Southern Hemisphere sky, every 3 to 4 nights, we will have imaged the entire sky. And then we will go back and do it again. And we will do this for 10 years continuously. Over time, we're going to be able to catch many objects that previously were undetected, especially objects that change in brightness or that move in the sky. And that's why we say here, we're going to be creating the greatest astronomical movie of all time. One of the really important aspects of Rubin Observatory is this ability to see the objects that change in the sky. Every night, believe it or not, we expect to see 10 million changes in the sky per night. And some of these will be things that we're familiar with, like variable stars and supernovae, asteroids, dwarf planets. Some of these are likely to be objects that no one has ever seen before. And so over a 10-year period, we'll have between 800 and 1,000 images of each part of the sky. And as that happens, we'll be adding them together. So over the years, we'll get deeper and deeper, more and more sensitive, and be able to detect more and more objects. We have 4 key science areas that our telescope is optimized for. One, as I just mentioned, was the changing sky. Another one is a census of the solar system. We anticipate quadrupling the number of solar system objects that we now know about. We'll also learn a lot more about our own Milky Way, its structure, its local environment, things like stellar streams, its formation, what kind of stars populate what parts of the galaxy. And finally, our telescope is really optimized to help astronomers in the study of dark matter and dark energy, because we'll be able to image billions of galaxies. And by filling in all the locations and what we know about those galaxies and clusters, it will give us much better insights into that last piece, dark matter and energy. Okay, I'm going to talk to you a little bit now about the education program that Justine mentioned briefly. We have 7 investigations. They are totally free. They are really built for you as teachers to use because they require very little setup time, no materials to acquire, no data to download, no special software programs to use. All you need to be able to do is have access to the internet, and you can visit these investigations, as we'll do together tonight, just by going to a website. These investigations are designed for introductory students in astronomy. We believe they work very well for students anywhere from advanced middle school through the introductory levels in college. We've designed these investigations specifically for people who are not going to be going into science as a field necessarily, but really for everybody who studies astronomy in middle school, in high school, maybe as a general elective course in college. And we've targeted our investigations really toward the most common topics that are likely to be encountered in an introductory astronomy unit or course. As I mentioned, these are easily accessible. You can use them in an online mode. You can use them face-to-face with your students. And something I didn't mention on the last slide is that we have some of our investigations right now available in Spanish as well as English. Excuse me. And even if you are teaching students with a different language, often we find if you use something like Google Chrome or a modern web browser that you can kind of right-click and translate, about 90% of our investigations translate and can be used in other languages as well. And if I didn't mention it already, everything we provide for you, the investigation, all the teacher support materials, the videos, they are totally free. They can be downloaded. They can be used in any kind of manner you want in your classroom context. Another caveat, and I know many of you are interested in this, is that all of our investigations eventually will have our own data in them. Right now, because our telescope has not yet begun producing data, we are using proxy data from other observatories, but all 7 of our investigations, even right now, are fully populated with authentic data. And so 3 of them we're going to be taking a look at tonight. Our solar system investigation, coloring the universe, and one on supernova. And you can see here in this bullet where we are pulling our data from for each one of these investigations. Now, many of you asked ahead of time about how do I get data, authentic data to use. And I wanted to mention just a few ways that we'll be making data available to people who are not scientists. So first of all, the easiest way, if you are an educator, for you to access our data is through our classroom investigations. Because what we've done is package them with data visualization and analysis tools. So you don't have to think about how to do that. We've created a scaffolded learning sequence. So we lead learners logically through, step by step, the process of analyzing this data and making sense of it. And then finally, we've done some curation behind the scenes. So we've done some pre-reduction of the data. So you don't have to spend time doing a lot of preparation before you can actually get to doing the science. Now, if you're not a classroom educator, maybe you're an informal educator or an astronomy popularizer, we will certainly be doing hundreds of citizen science projects. Rubin Observatory has partnered with Zooniverse, so we'll be using their platform. And our part in this process is really not designing the citizen science projects, but working with scientists who want to design a project to make sure that it works well, that it makes sense to the people, and just to help them facilitate building their projects out on the Zooniverse platform. I think as early as the end of this year, you may begin to see some Rubin citizen science projects, but certainly in a few years, you'll see a lot of them. Finally, if you're just an amateur, not just an amateur astronomer, because I'm an amateur astronomer and very proud of it, but if you're an amateur astronomer, maybe you're not involved directly in education in any way, you will immediately begin to see our alerts when our telescope goes online. An alert is a notice that the telescope has detected something that has changed in the night sky. We're expected to get 1 million or 1 to 10 million alerts per night. And so those little thumbnail images and a notice of them will be streaming constantly, as they're detected and posted just a matter of seconds after the data are processed. So there are going to be many ways that you can access and look at data, even if you are not a scientist. And because of this, we say this is going to be the first time that so many people are able to use and look at data and make some sense of it in a very broad spectrum of cases. And we're very, very happy and hopeful that we can make that happen for you. And now I think, Justine, you're going to take it from here.
Yes, I can do that. So all of our investigations are designed to support the U.S. science standards, specifically the next generation science standards, and the steps for having a more three-dimensional approach to learning. So we've designed our investigations to do that as well. And our other audience is also in Chile. So that's where our observatory is located. So we want to focus on Chilean education, and the Chilean Curriculum Nacional actually has a similar three-dimensional approach to learning and doing science. So all of our investigations come with a teacher guide that breaks down the standards and the different elements of each standard with how we're addressing it in the investigation. They all come with this, we call it a tri-colored learning statement as well, where you can see how students are using each of the dimensions of the next generation science standards in the investigation. So we make sure teachers have access to that as well. And then I just want to point out some user-friendly features for you. So when students open the app, there are some design features that were made so that we can make sure that students have an easy time accessing and going through the investigation. So one thing that we wanted to point out is there's a progress bar at the top of the investigations that shows students how far along they are in the investigation. And there's also these thumbtacks that point out the different sections of the investigation. So the first thumbtack marks the end of the first section, and then the second thumbtack marks the end of the second investigation or second section. And these are also great places to stop the instruction and do some formative assessment before students move on with their learning. And we provide some formative assessment questions for you, and we'll show you that later on if we have time. We also have a table of contents. So on the right-hand side, if you were to click on table of contents, you will then find a drop-down menu so you can see the different pages of the investigation. Now, we also include a glossary as well to just break down some new concepts for students or new vocabulary terms. So if they click on any of the text that's in teal in the investigation, a new page will pop up that just gives them a definition of that term. And then we also have a language selection. So some of our investigations, we have like 2 different platforms that the investigations are hosted on. And one of them might have a toggle between choosing English and Spanish, and the other version has a drop-down menu on the left-hand side where you can select your language between English, Spanish, and some of them are also translated into French. And then artists pointed out really well that if you were to right click and you're in Google Chrome, you can use Google Translate. And we've had some workshops in South America, we've had some workshops in Asia, and the translations seem to work really well for their languages too. We can't guarantee that everything's accurate, but if you are really interested in using these investigations in your country, but you think language might be a barrier, we highly suggest you check out Google Chrome, Google Translate. And then we also have something that we call like a reference modal or a pop-up. And it's usually for a concept or an idea or like a reference guide that we have noted earlier in the investigation. And it might be useful for students to use later in the investigation. So instead of them like going back page by page by page to try to find where this great reference was, we've put these little modals or icons on certain pages where we think it might be useful for students to access. So that's another great feature that makes our investigations very user-friendly. A common question that we get asked is, well, how can I have my students turn in their work? How can I like just track their progress? We don't have an educator platform where you can see students' work live and how they're doing. So what students need to do is on the left-hand side, they're going to click on review answers, and then their whole answer page will pop up. They can type in their student name, and as they scroll to the bottom of their answer page, they can then either print their answers or export their answers and turn it into digitally or as a hard copy as well. But then what about saving work? So this was another issue. There were a lot of schools where there was like a class set of computers for students, and the students wouldn't finish the investigation in one class period. So all of our investigations take about 2 hours to complete, and a lot of our classes are less than an hour long. So to solve that issue, we created student accounts and educator accounts. All a student account does is it just saves their work as they go, so they can just log in to their computer the next day and pick up right where they left off. And if you don't want to create student accounts, you don't have to create a student account. Their work is just not saved as they go from page to page. So that's one feature to note. Educator accounts are, they also save your work as you go, but what's really great about an educator account is you don't have to type in answers on each page to go to the next page. So for students, they have to answer every single question on the page before they can go to the next one. They don't necessarily have to be correct in their responses, but they actually have to do the work before they can move on. But as educators, we might need to help a student that is like, let's say on page 20 of the investigation, and we need to get there quickly. And we can't do that if we have to type in all of our answers as we go. So that's the importance of creating an educator account. And we can talk more about that later. If that is a question that pops up, we can show you how to do that as well. Also, there's real people in this team. So if you have any questions, you can always email myself or Artis. But if you just email education@lsst.org, it will also go to Artis and she can answer any questions. So there's people that can help you live, and we try to be as quick as possible because we know sometimes you have a short period of planning and you want to use the investigation as soon as possible. So we are here to support you. All right, let's take a look at one of our investigations. Our goal is to try to get through 3 investigations today. Artis just put a link in chat. You are welcome to open it and browse through it on your own, but I'm also going to take us through it. I have a couple of screen recordings as well that I wanted to share with you of just some really great highlights of the investigation. Now, our investigations are like 50 questions long, so we just don't have enough time to get through every single page. So I'm just going to do a quick preview of what to expect and some of the awesome design features of every section. So again, feel free to check it out with the link Artis just put in chat. But this is called Surveying the Solar System, and this is a fantastic investigation where students learn about objects that are in our solar system, other than the planets and the sun and moons, what else is out there? So Rubin Observatory is going to excel at detecting faint objects, and it's going to detect thousands of new solar system objects. And with that information, scientists will be able to classify them into different groups of objects, and they're going to be able to understand how the solar system came to be as it is today. So first, we want to know, well, what types of groups of objects are there? And that's what this investigation does with students. At the beginning of the investigation, of all of our investigations, it gives background that students need to then be successful at analyzing data. So we want them to be able to make sense of what they're looking at with like their histogram or some sort of plot or other data visualizer. So you'll notice that trend in every section 1 of our investigation. And for surveying the solar system, we introduce students to semi-major axis, eccentricity, and inclination. We have these great little mini video clips to help them try to visualize what these new vocabulary terms are. And here's another preview of section 1, where, okay, once students understand what eccentricity is, what inclination is, what semi-major axis is, then they are able to look at these histograms and they try to then find all of the properties of these different solar system objects. So they go through and they learn about near-Earth objects, they learn about comets, they learn about trans-Neptunian objects and main belt asteroids as well. In section 2, once they've learned about our different types of objects and their orbital properties, they then get to visualize these objects. So they're given what we call an orbit viewer. And so they're looking at the orbit viewer, they're looking at the different spatial representation of this small group of objects. They can click on each of the objects and some data will pop up about that object as well. And they try to figure out, okay, am I looking at comets? Am I looking at near-Earth objects? Am I looking at main belt asteroids? So that is section 2. And then in section 3, so now they have a really great understanding of the different groups of objects in our solar system and what their orbital properties are. But then we give them this scenario, which is actually, it's real data that we give them. And we say, hey, Rubin Observatory is going to discover lots of new objects. They could discover brand new type of group of solar system objects. And so we give them this new group of solar system objects. We give them the histogram and they analyze that data. And then we also give them models. So they have to evaluate these student models to decide, is student team A, student team B, or student team C, which models best represent the data and explain why. All right, and so that's surveying the solar system in a nutshell. So now I'm going to turn it over to Artis, who's going to give a very quick preview of Coloring the Universe.
Hi, thanks, Justine. So Coloring the Universe is an investigation that encompasses a lot of different aspects that you might study. And if we begin by taking a look at it, what we're doing here is we are going to be using the capability of the Rubin telescope and camera system to look at the universe through 6 different filters, and therefore being able to understand different kinds of science, because different sciences use different filters to study wavelengths of light that are most important to them. Using these filters, we are able to create multicolor images. But we go a step beyond just making a color image. What we do is we teach students how scientists use color to visualize data. We teach them the process of what's called chromatic ordering. And the end project here is that students create their own image that communicates a science message that they've been researching. So first section, just like we were looking at in the last investigation, we'll just give you some sample snapshots of the different sections, is an introductory section about understanding electromagnetic waves, wavelengths of light and color, and then how filters work. So you can see the widget that we just played will show you that you can choose a filter to put in front of the light coming out of the prism, and we can see that filters are allowing certain wavelengths of light to be transmitted. The next section is we build the concept of how images are colorized. Many students don't understand that an image, when it is detected at the image sensor, the CCD, is not in color. It's just in black and white. And even if we put a filter in front of it, like you see here on the right, the red, the green, the blue, it's still only in black and white. So there's sort of a two-step process that we have to kind of teach in this section. One is the concept that image sensors detect levels of light, but not color themselves. Filters allow a certain amount of a certain set of wavelengths of light to be analyzed. But then the next step is actually colorizing the image. So in this example that you see on the left, students have 3 filters, R, G, and B. They have to then not only turn on the filters, but they have to select a color that they're going to assign to each filter. And the concept here is they are trying to create the image on the left to be as close as possible to the image on the right, the full color image, by assigning those colors to the filters, changing intensities. Now, the Rubin camera has 6 different filters. Some of the filters go into the ultraviolet and some into the infrared. And they're a little bit different than a traditional filter like we show in the first part because they're what we call broadband filters. And this graphic on the left introduces that concept of a broadband filter. So if you look, for instance, at the R filter of the Rubin camera, it's picking up wavelengths of light all the way from green to red. It doesn't mean red. R in this case is just the name of the filter that pulls all those wavelengths of light in. And so here we're introducing a sort of a new use or new thought of how filters might work, that they'll allow a whole range of wavelengths through. The next section, in section 3, now that we've kind of built up the concept about how color images are made using filters, is we're going to take a look at 3 science cases. And we've chosen these 3 science cases to match some things you might teach in an introductory astronomy course. One is star temperatures, using colors to figure out which stars are the hot ones, which stars are the cold ones, cooler ones, by looking at their brightness through different filters and then assigning colors to them. The second concept is, where are stars forming in spiral galaxies? And so again, using filters, students look at how the galaxy changes as we examine it in different filters, and then they assign colors to that to build out an image to show star forming regions. And the last one deals with redshift, detecting faraway galaxies because their wavelengths will be stretched out more than any other, so they will be brightest in the longest wavelength filters. Now that we've introduced 3 different applications of science, we bring in the Rubin color filter tool, which you can see is just like a bigger version of what the students used previously. But instead of having 3 filters and 3 colors to work with, we now have 6 filters and a range of colors to work with. We bring in the idea that you don't have to use all the filters, just filters that are important for the science case you might want to study, and that you don't have to use only red, green, and blue. You could use other colors as well. And so in this section, students practice making an image using the Rubin color filter tool, And then they come up with a science case they'd like to study. Maybe they want to study star-forming regions and galaxies. And so they have to decide what filters they'll use. They can choose different galaxies that are in a drop-down menu here that you see on the right. They can turn on those filters. They can assign colors to them and adjust intensities. And so the end product is a color image that they create. And then they have to explain how the colors in their image show what it is that they're trying to communicate, and really kind of walk through that whole process of why did you choose the filters you did, why did you put them in the colors you did, etc.
Awesome. Thanks, Artis. And the last investigation that we're going to explore is exploding stars. And I just want to remind you, there's more than 3 investigations. There are 7 in total, but we only have an hour. So we're just going to go through these 3. So exploding stars, this investigation analyzes light curves to identify different types of supernovae and determine the distance to host galaxies. So Rubin Observatory is going to be able to detect millions of type 1a supernovae. And why this is so exciting is because this specific type of supernova are used to measure distances in space, and we can help get a better understanding of the expansion of the universe over time, how things have changed over time. So in this investigation, students are introduced to the two different types of supernova. So type 1a and type 2p. So they're introduced to how they form, how they happen, and then their light curves as well. So in the first section, they're trying to focus on, okay, what are the differences in these light curves? And here we have the light curve for a type 1a supernova. Okay, so section 1 just builds that background of the 2 different types. And then in section 2, students, they use this widget to try to figure out, okay, where is this supernova occurring? And if they can find it, that's great. The light curve will pop up. And then they try to analyze this light curve and they decide, okay, is this a type 1a supernova or a type 2p supernova? In section 2, they also learn that type 1a can be used to measure distances in space because they're standard candles. And so we introduce that concept to them, and they use this widget to look at a type 1a supernova light curve, and they try to find different values. So they try to calculate its delta M15. So I'm going to just play this one more time. They try to calculate the delta M15. So this area in gray here, okay, so it's about 15 days after its peak brightness that they try to match this model curve for the supernova. And then they can also find its apparent magnitude as well. So they use this widget. I like the user-friendly feature where it does a lot of the calculations for you, because then we can use these values. I'll show you on my next screen here to try to determine its distance. So we found its apparent magnitude. We found the delta M15 by fitting the light curve to this type 1a supernova. And students start to type these values in. They can see the equations, so they know it's not magic with how our calculations are appearing, but it does save some time instead of calculating out the entire distance modulus. Then they're able to calculate the distance. I'm just going to go fast forward. So we start students off with a practice for this investigation. So they're practicing finding the distance first, and they get a little reassurance on that first page with if their distance is too far, if it's too close for that supernova to have happened. And then we give them 3 different supernova, and our data is randomized. So actually not every student gets the same set of 3 supernovas. So you might have one student sitting next to another student, and they are looking at 2 different data sets. And then what students do is they get to visualize their 3 supernova on this map. And it has a histogram as well that shows the different distances in space of some of these type 1a supernova and where they exist. And they can try to figure out how their 3 supernova fits within this visualization sky map. Okay, so that's just a quick exploding stars, coloring the universe, surveying the solar system in a nutshell. But we have other educator resources to support you in doing these investigations in your classroom. So as we've mentioned, they take about 2 hours to do with your students, but you might want to see where are my students' understandings currently at. So we have designed a really short pre-test. It's about 10 questions long for each investigation. They are multiple choice in style, and it comes with an answer key. And we also break it down by which element of the next generation science standards each question is supporting. And you could also give this pre-test as a post-test as well. So after they've done the investigation, see what they've learned, and you can use that to gather gains. We have a phenomenon activity, or you can call it a warm-up activity if you want, to help engage your students, elicit their ideas, have them be the leaders, have their questions lead you into the investigation. This is just an example phenomenon activity. It's actually a video, but I just have some screenshots here. So it's a time-lapse video of asteroid discoveries from 1970 to 2015. And it shows these asteroids starting to appear over time, and like certain booms of the asteroids. As we get more technology, we have discovered more asteroids. But you see these different colors. There's a green group, there's a red group, and I think there's an orange group there as well. Students will probably start to notice that there's planets too. The little blue or teal colors are planets, and it only goes to Jupiter. So we might have questions. Well, are there groups of objects that lie beyond Jupiter? You know, what do these different colors mean? And we can use the solar system investigation to answer those questions. So that's one way to elicit student questions. And so we have a similar phenomenon activity in all of our investigations that's used to help students, you know, use their own thinking, get them curious about their learning. And then we have these formative assessment questions that are really great to ask students at each of the checkpoints. So you'll see this checkpoint icon at certain pages of each investigation, and we recommend you stop instruction and you ask some questions. And either you can come up with the questions, or we do have a set of questions ready for you as well, as well as an answer key to those questions. And we also have questions that you could use at these checkpoints to connect back to the phenomenon. So this is just an example of surveying the solar system on the right here. If you happen to use like a drive-in question board to post your students' questions, we give you guidelines for doing that. And then we give you a sample activity that you could do to connect back to this asteroid video as well. So at each checkpoint, students can be connecting back to the phenomenon and see how their thinking has changed over time and what questions they've started to answer already on their own. As I've mentioned, it's a little overwhelming. There are like over 50 questions on some of the investigations, and as teachers, we do not have time to sit down and grade 50 questions for each student. So we have designed a document called the Key Assessment Questions, and this, I like to call this these are the money questions. So we've highlighted the questions that summarize a student's understanding of a particular concept that was covered in the investigation. So you could use this to just figure out, okay, what questions should I pay attention to? And if students are getting those questions wrong, these money questions wrong, you should go back and have them, you know, revisit one of the sections of the investigation. And finally, these investigations are incredible to do collaboratively. We encourage students to be working together. But if you need to get individual scores, we've also designed a summative assessment for each investigation. And the summative assessment, students are applying the same skills and using the same concepts that they've learned in the investigation, but just with a new assignment, a new task in front of them. And if they were able to successfully go through the investigation, they can successfully show their understanding in the summative assessment. This also comes with a scoring guide based off of standards-based grading. So we show you that 3 is meeting the expectation, and we give you possible scenarios for what a 2, for what a 1, for what students, they're not understanding the material, what those possible answers would look like. And then we also give you examples for if a student is exceeding our expectations. To access the assessments, you do have to create an educator account. It could be the same exact credentials that you use to get into the investigations, but we do not want students to be able to have access to the assessments. So it's a little bit hidden with how to access them, but if you go to the educators page of our website, you'll be able to, once you click on assessments, it's going to say, whoa, 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 you can't go any further unless if you're an educator, and then you would sign in with your account. Artis and I, we are the ones who actually approve people who get the educator accounts, and we do a little bit of vetting to make sure you're actually an educator so you can access the assessments.
Okay, well, if you're not totally exhausted yet, we're going to introduce a few other ideas to you. For each one of the investigations, besides all of those assessments and the phenomenon, we have an extensive teacher guide that provides a lot of background for you. If you're new to teaching astronomy, there are some great sections in there that will tell you what kind of questions students are going to ask you and how you might answer them, and also where are they going to get confused, where are the hands going to go up. So you kind of prepare and thinking about a bridge to learning from that. Each one of our investigations comes with about a 15-minute science video from an expert in the field, introducing the concept that students are going to be studying and why it's important. Right now, we have those videos available only in English, but we are working on a series for Spanish, and we hope we'll have more than half of them done before the end of this year. We have speaker slides for those videos too. So you can either watch the video yourself to get some content background, or you can show it to your students, or just use the speaker slides if you'd like to show key aspects of that video to your students. So everything you see here on this slide in teal or kind of a green color, that's for each investigation. But besides that, we have other general resources on our Rubin education pages, and those will be a program guide which explains the design of our investigations, FAQs, and also a section of professional development resources. One of the key features I'd like to point out there is that we have a series of archived videos of all of our webinars. So if you want to do an investigation, you're not really sure what a good overview of it is, you can go and find that investigation, watch the video on it, or just watch the science video if you prefer, and they'll give you a little bit more background. The main website of Rubin Observatory has also general resources that you can use. The gallery has great images. It has a set of slideshows, like, slideshows about asteroids and supernovae and things like that. We have a brand new media kit that was just introduced in January. It's full of beautiful images and resources, and it's pretty non-technical in terms of the language written, so that it's pretty understandable if you want to read about different aspects of the observatory or its science. And we have other things there too, like a game that shows how survey telescopes work. We have a series of 2-minute animated videos available in English and in Spanish that introduce concepts. like exploding stars. And so we encourage you to check out the entire website and not just the education pages. And spoiler alert, because we are going to have our first look later this year, we're going to be adding a lot of new resources between now and the middle middle of July or so. So just be aware that one time is not enough. You have to come back and visit and see what's new. And finally, if you would like us, Justine or I, to do a presentation for a small group of your peers, maybe you've got a department or a science meeting that you would like us to share this kind of presentation at, we will do that totally free for you as long as it's virtual, or if you want to pay to send us, we'll come and do it for you. Anyway, just contact us and tell us what you need. And as Justine said, you can also just throw us a quick question and say, I'm stuck on this, what do I do? And we'll get to you as soon as possible to help. We have a community of practice on Facebook. If you do social media, it's called Rubin Observatory Educators. If you would like to join our community of practice there, just find it. You have to agree to the rules and answer 3 questions, and then you will automatically be admitted to that private group. If you don't do social media, we do have a dedicated email discussion group by the same name. In order to get on that, when you fill out your evaluation, which you'll do in a few minutes, there's a box you can check to say, I'd like to be added to that, and we'll get that done for you by tomorrow. If you don't fill out the evaluation, couldn't find it, email us and tell us that you'd like to be added to that list. And that list is specifically to discuss Rubin investigations and implementation and share ideas with each other and so on. Okay, we've got some upcoming events that we'd like to tell you about. Some of you are familiar or might belong to the American Modeling Teachers Association. We are doing a series of webinars with AMTA, and our next one coming up is April 1st, where we're going to be unpacking exploding stars from a modeling perspective. These modeling webinars are free to everybody, but you do have to register in order to attend. There's another one, a new science series we're going to be starting later in April, and it's going to kind of explain the science behind some of our investigations and also just kind of give you some heads up about the best way to use the tools in the investigation. If you're interested in that, our first one is also going to be on exploding stars. And it'll be great for you if you feel like you need kind of a boost of your background for that content knowledge, or even how to like go through the investigation and show students how to optimize using the tools. So you're invited to that. And we will put a link in chat if we have not yet. Okay, I see Justine's already done it. There's a link in chat that takes you to our calendar of events. And that would be an important link to keep, because even after these 2 are over, we will be adding new events to our calendar of events. So you can always see what's available for you to attend. And now we're going to kind of pivot away from Rubin Observatory for a minute. Christine and I are board members on the National Earth Science Teachers Association. And we have a fantastic 1-hour webinar for you coming up this Thursday. And it really is amazing. And I can tell you that from personal experience. I don't know how many of you are familiar with the Civil Air Patrol in the United States, but they have just a wealth of opportunities for you as teachers, whether you teach at the elementary level, middle school, high school. You can get free flights over your school. You can get free STEM kits. There's aerospace research projects you can get involved in. Just an amazing set of tools and opportunities for you. So if you would like to register for that event, you can still do that. I guess what we're going to need to do is send a link, Christine, because right here, this is just a picture of the event registration. So maybe I can scramble and find that link in the next 4 minutes. But I invite you to come to that Earth and Space Education Hour. We're doing like one webinar a month for the Earth Science Teachers Association, and this will be our first one that we're kicking off with. Okay. So we would like to thank you very much for spending an hour with us. We'll hang around to answer questions as we are able. And oh, great. Okay, I see Ross Connor says he's a member of the Civil Air Patrol. Yeah. So if you have any questions about any of this, yeah, please feel free to ask them. I know we have one question already. Christine, how would you like to handle this? Do you want people to unmute themselves, or should I do that?
Yeah, if you want to unmute, there was a good question in the Q&A that I was going to let you guys answer. That's the only one. It looked like the other person answered themselves. And then if you guys want to come off mute, I do want to be respectful of everyone's time. We're coming up on the hour. So I will stop recording at the hour. But if you want to take that question in the Q&A, and we can go from there.
Sure. Ross, you ask, you describe your Chilean project as a 10-year movie documentary. Can it also be described as a book with 10 chapters updated each year with a concluding chapter? Or must we wait until the 10-year period is completed? I'm hoping to learn about smaller galaxies that up to now have been invisible to scientists. So my answer is yes and yes. You can do both. How many movies do you know that are created from books, right? So we have a data products release every year. The first one will be about a year after we begin taking data. It'll be the first 6 months of Rubin data. And then every year after that, there will be a new data release. So those are your chapters of the book. But also over time, we're blending those all together and we're learning more and more, right? So there's kind of a emotion element involved in it too, as we see things changing in the sky over those 10 years. So that's kind of how I think about the movie element of them both.
That's great. If anyone has a quick question and you want to come off of mute, that would be fine. And then I do want to be respectful of people's time. Thank you so much for answering that, artist. That was well done. And I did put a link to the other PD that artist had mentioned. I put a link to that registration page. So you can see that there. If there are any questions, we'll open it up now. Okay, I'm going to take that as a no. Thank you guys so much for joining us. Thank you, Justine and Artist. Thank you guys for sharing an hour with us. What a phenomenal resource. This has just been great. Please give them a follow over on Facebook. Be sure to follow on LinkedIn and Facebook, the IAU US NIAC group, if you're not already. You can follow us there, where we will be hosting these every single month throughout the year. We have SLU next month. That'll be very exciting. But this has just been phenomenal and just so cool to see. I've been watching what they have been doing over at Vera Rubin with these investigations for a lot of years, really, I think since the beginning, and really seeing how these have progressed. And it's just such a phenomenal resource. So I hope you guys are able to immediately take this and put it to use in your classes. And yeah, just thank you again. And please stay tuned for more. And be sure to sign up for the additional webinars offered by all of us. Thank you guys so much. Have a wonderful evening or morning or afternoon, wherever you are. Thank you.
Thank you.